Hi, and welcome to the first podcast in the Essentials 4DS Math. We're looking at Chapter 1, which is dealing with linear relations. And in fact, today we're going to be talking about linear relations in tables and graphs, and that's section 1.1. Now, I have a quick sort of graph up here that's going to sort of illustrate my point when we look at linear relations. And I used one from the textbook, and I took the first one, which is the, if one cow is traded for 3 sheep, 2 cows can be traded for 6 sheep. And if I was to plot that as a relationship, so if I was to say for every cow on this, which is my x-axis, and this is my y-axis, would represent sheep, then if I sold 1 cow, the value of that would be 3 sheep. Now, if I sold 2 cows, the value would be 6. And if I sold 3 cows, the value would be 9. When we plot that, we get a straight line. And not only do we get a straight line, we get a straight line moving through this point right here. And this point right here is called the origin. Okay, now, the slope of this line is a constant, and it's a constant that we can graph. And so the formula to calculate slope is just rise over run. Okay, so in other words, to express that another way, the slope is equal to my second point on a line in terms of the y-axis, subtract the first point on the y-axis. So rise 2 minus rise 1. Same is true for the run. It's the second point on the x minus the second point on the y. And so this is what we call a direct linear relationship. A direct linear relationship is one that forms a straight line, but also includes this point right here, 0, 0, as part of that line. So let's look at an example. And this example is right out of the textbook. It's the example 1. So I have the automatic watering system in the greenhouse. I want to measure the flow rate, and I want to, I know that a barrel holds 340 liters of water. So at time 0, I'm going to have 0 liters. It's empty. And then what I'm going to do is I'm going to let the water start to flow into it, and I'm going to time it until I get to the top. Now I know the top is 340 liters, and I know that after I time it, it takes 16 minutes and 30 seconds in order to do that. Now, when I look at this, automatically I'm going to ask myself, is this a linear relationship? Now, to figure out if it is a linear relationship, I can go to a graph. And I can go to a graph and I can look at what is the relationship between these data sets. Now, in order to do that, I need to understand a couple things. So I need to understand independent variables and dependent variables. Okay, essentially the way I remember dependent and independent variables, independent is what you change, and dependent variable is what you measure. Okay, so if I look at my experiment here with the automatic watery system, I'm obviously changing the time, right? Because I'm starting at 0 and I'm letting the stopwatch go as I'm pouring water in. And time is what's sort of being changed on the independent variable. And so for this experiment, the independent variable would be time, and that time measured in seconds, make sure that if you have a point like 16 minutes 30 seconds here, that you convert it into seconds, the whole thing into seconds. And then finally, my dependent variable, what am I measuring? Well, I'm measuring how much water I'm going to get. So that is my dependent variable, and that would be volume of water. And that, of course, is in liters. When I graph this, what I find is that point 1 is that origin, is at 0, 0, and point 2 is somewhere over there, represented by 340 liters at 16:30 seconds. Okay, just like your textbook has as an example. When I join those two up, I get a straight line. And that tells me right away that I have a linear relationship. Now, going further than that, we can calculate the slope. And the slope in this line is going to give me the rate. Okay, because I'm looking at something over time, I'm looking at a rate. And in this case, it would be liters per second. So volume of substance over time. So to do that, I've got 2 points. I can go back to my original formula and I can apply it into my slope formula. So m equals y2 minus y1, x2 minus x1. And remember, we've already converted the x's into seconds. So when I apply this, my y2, I finish off with 340 liters. I'm starting at 0. My x2, my time, 16 minutes 30 seconds, which converts to 990 seconds, starting at 0. And when we actually calculate that out, we get 340 divided by 990, and my slope, or my rate, is 0.343. Now, because this is a rate, my units would be liters per second. Okay, so what does that mean? That means by looking at this graph and looking at this example, the automatic watering system is delivering to those jugs 0.343 liters of water every second. Okay, and that gives me sort of the rate or the speed at which the watering system works. Okay, so that's the idea behind direct linear relations. Now, the other type of linear relation is partial linear relations. Partial linear relations are relations that do not pass through the origin. So I'm using the example right out of the textbook. The partial linear relation in this case was the wedding reception. And obviously, our receptionist or a coordinator for our banquet hall is not going to start her rate out at 0, right? She's going to have a base rate. And in this case, the base rate is $500. That's sort of the base cost to rent the hall, and then it goes up per number of people. So number of guests. Now, that's our independent variable, right? Because it's on the x. And the cost, that's what we're measuring. So every time I change the number of people, I can measure the cost. The cost also changes. Okay, and so the cost becomes my dependent variable on the y. Okay, now this is a partial linear relation because, again, it's not passing through 0, so 0 is right here. It's still linear in that we get a straight line, so we could figure out, for example, on this, we could figure out the cost per person, right, after that $500 base price. And that's based on this line here and calculating the slope of that line. So if I wanted to take the difference between, I think she was looking at 50 and 200. So she wanted to figure out what the cost is between 50 and what the cost was between 200. And so to do that, we can figure out the cost per person on this line, picking 2 points on the line and calculating the slope. And the example given here does just that. So again, applying our formula, y2 minus y1 over x2 minus x1. Picking 2 points, and I'll use the ones right out of the book, make it easy. So we're looking at 5,000 minus 2,000. Okay, so we pick 2 points. 1 point here on the y and 1 point there, and again, it doesn't really matter. I recommend picking points that are easy to measure. And then over x2 and those points, so at 5,000, right, we're looking at 150, and at 2,000, we're looking at 50. So when we calculate that out, 3,000 divided by 100, and so our rate in this case is 30. Now what does that mean? That means that the price after a $500 base is $30 per person. And that would give you a good indication if you were actually going to use this banquet hall. Using this graph and understanding the relationship would give you a good way to actually budget. Okay, so that's a linear relation, a partial linear relation. We looked at direct linear relations. The last thing I want to talk about is a nonlinear relation. So a nonlinear relation, if we were to look at both, and in fact, let's compare all three. Here is a direct linear relation, right? We already talked about it going through 0, 0. Here is a partial linear relation. It's linear, but it's not going through 0, 0. And a non-linear relation would obviously not make a straight line. Okay, so that's the first chapter of this podcast.